Hello, I'm Thomas Kühne from the Technische Universität Berlin, and I will present you the bringing hybrid analog-digital beamforming to commercial multi-user MIMO Wi-Fi networks demonstration here at MobiCom 2020. First, let me give you a short introduction and motivation. In 2013, the 11AC extension to Wi-Fi introduced multi-user MIMO with a maximum of 8 spatial streams, which is great because it means you have a very high data rate and you actually have 8 concurrent users using those 8 spatial streams. But it was only slowly adopted. At the moment, in 2020, you mostly have systems with 4 antenna devices and 4 spatial streams. So what might be the problem? First, the number of antennas is equal to the number of spatial streams and number of users. So you actually have channels from the users which are not independent to each other with this configuration. And this is limiting the multi-user MIMO gain so that at the end it is lower than the number of hardware streams you support in your card. Qualcomm actually wrote in 2015 a white paper where they investigated this, and they write that with 4 antenna elements you should support roughly 3 users and 3 spatial streams, because you cannot cope with more interference in the system. You can find this in the reference here. So what could be solutions? There are solutions already in 5G, and it is increase the number of antenna elements to be much higher than the number of users. In 5G, this is done in a full digital system where each antenna element has its own TX-RX chain. But this is too costly for Wi-Fi. So another approach, the hybrid digital analog beamforming, is proposed in the context of millimeter waves, and it actually solves the cost and complexity issues, so it might be a candidate for Wi-Fi. What it basically does, it has an analog precoder and a digital precoder. The analog precoder reduces the number of antennas to a lower number of RF chain. So the concept is that the analog precoder forms beams towards users in directions, and with this already decreases the interference and decreases the number of antennas to a lower number of RF chains. A digital precoder can then cope with the rest of the interference and can actually achieve a very high multi-user MIMO gain, which would be close to the number of RF chains. What do we require? Of course, we require the hardware, but also we require information of the location of the users. So where should we beamform towards? And for that we need some algorithms, and the process for these algorithms we call beam alignment further on in the paper. You of course also need some precoding algorithms in digital and in analog, and on top of that you need a scheduler. A scheduler would decide when to beamform towards which users and also tracks users. So in our prototype implementation, you can see that we have implemented actually the 2x16 antenna with some analog beamforming module and some hybrid control software in a host PC. And this is all on top of commercial Wi-Fi cards. So one commercial Wi-Fi card with 4 RF chains. So we are using the default Wi-Fi card. If you would implement a protocol in a scheduler, it would basically get an attached user, then run the initial beam alignment, which we have implemented. It would estimate the angle of arrival and then beamforms towards this user to basically increase the multi-user MIMO gain. Following, the protocol would continuously also track where the user, if the user is moving and if new users are attached. So we implemented the beam alignment, and even during the beam alignment the user can communicate with the internet through the host system, through the access point, but we haven't implemented this tracking scheduling. So in terms of hardware, we have our custom antenna array, which you can also see behind me. We have our analog beamforming module, and both of them, the hybrid system, are connected to the commercial Wi-Fi card in our host PC, which is a standard Intel PC, and the Wi-Fi card you can commercially buy. It's based on a Qualcomm chip, but with this limitation of maximum multi-user MIMO gain of 3, which you will see in our results as a maximum. In terms of software, we are running on Linux, and we use the default FRS Wi-Fi driver and host APT software for access point functionality. The hybrid software is also implemented on this PC, but it's completely decoupled from the data path, so the users can continuously communicate with the internet through our host PC and the access point, and we run beamforming on top of it, but the users in the Wi-Fi, they don't know that. Like the Wi-Fi protocol is not changed. The beamforming algorithm is actually implemented from this paper we reference here, and the nice part of this algorithm, it uses power measurements. For example, RSSI values, and those power measurements we can get from just normal traffic from the driver, the RSSI value. So everything of the hybrid system is running on top of just standard traffic. So this is how our demonstration and access point part looks like. So you have the hybrid of the antenna array and the analog beamforming connected to the host PC, but we also introduce a 4 antenna element system, which is connected via an RF switch to the host PC to basically run a comparison between the hybrid system and the default 4 antenna element system. The room with the users is a teaching room. You see we have separated 4 users in this room, and we are running the experiment on channel 1 of the 2.4 GHz system band. And for measuring the performance, we use IPER3 to measure the throughput with UDP packages in downlink. So this is actually the rate the users would see. The users are Intel PCs with default Intel Wi-Fi network cards. And we run a throughput sweep when we fix the MCS values of the access point. So to actually see how the base system with 4 antenna elements compares towards the hybrid system. So now let's run the demo actually. So here you can see the 4 users connected via SSH, so then we can control them. And I already started the access point. So let's attach the 4 users. And then check if they are actually connected to the station. Yes, now the 4 users are attached. Usually takes only 1 to 2 seconds. Then we can run the beam alignment algorithm, which sweeps through different patterns and at the end uses some math to calculate the location where the users are, and then we point the beams towards the users. So here we estimated and we set up the beams. So now we can actually measure the performance comparison between the 4 antenna element system and the hybrid system. So we plot once the real throughput with an optimal value as a comparison, and then the multi-user MIMO gain, which has a maximum of 3 because the Qualcomm card is limited by 3 users. And on top of the 4 users, we use time division multiplex, or the Wi-Fi system actually uses. The red curve is the MCS values. So you see the MCS increases, the rate increases. At the earlier MCS values, 0, 2, and 4, the gains are actually pretty much the same between the 2 systems, the 4 element and the hybrid system. But as soon as the MCS values go to 6 or 8, the 4 element system cannot cope with the interference, and it actually drops to lower values of the multi-user MIMO gain and respectively also of the throughput. So you see it also gets some timeouts, so the measurement takes longer because the connection is in such a bad shape because we really force MCS 8. I can also show you some pre-recorded sweeps where we sweep actually all MCS values and not only 4, like 0 to 8 in 1 steps. And you can see that the 4 element system drops after a certain limit when the interference gets too large to lower values, and the hybrid system stays the same. We have a second experiment where we actually use only 2 users but 2 streams per user, which means a MIMO gain of 4. So we use multi-user MIMO gain of 2 times 2 normal transmission beamforming. Qualcomm supports this mode, and actually we get a gain which is close to 4, so between 3 and 4 with training overhead of the MU-MIMO. And we also see that the hybrid system supports this case with a very high gain, whereas the 4 element system drops to lower values. So now let me only thank you for watching the video, and if you have any questions, you can contact me with this email address. So thanks for watching.